there's the situation, and we came up with a graph, and we came up with our equation. Now, we're going to look at what if I'm given the graph and the situation. Suppose you have an annual fee for attending a public university were $7,000 in 2010, right? So we're starting with 7,000, and the annual cost increase is shown in this graph. So we have the 0.07,000 labeled and 1,700 labeled. So if we're going to write an equation, we already know that our A is equal to 7,000. So Y equals 7,000. Now let's find our B. I went from 7,000 to 7,700, so 7,700 divided by 7,000, and I get 1.1. Makes sense. I've got a B value that's greater than 1, and I have a growth model, so we're kicking it. I know I went from 0 to 1, so I didn't have to worry about taking any special roots here. It's all to the first, and then X is the number of years. Notice it's after 2010. So 2010 was year 0. That was my start value. So let's say you're in 8th grade. If we have the equation y equals 7,000 times 1.1 to the 5th power. Why did I pick 5? Well, let's hope that in 5 years you will be graduating from high school and looking at going to college. So if I punch in 5, I'm going to raise it to the 5th, multiply it, and that means that the fees are going to be $11,274, right? If you were in 7th grade, then we would plug in 6 for X. If you were in 6th grade, we'd plug in 7. Okay, so far so good? All right, we're going to flip over and we're going to do a couple more questions on this graph. So the next one asks, what was the cost in 2000, assuming that the rate of increase was the same during the time of 2000 to 2010? Now, 2000 was 10 years ago. So now my exponent is going to be -10 because I'm actually traveling back in time. So if y equals 7,000 and my multiplier is still 1.1, and now I'm going to have a negative exponent. So I should come up with the fees being less. If you punch that into your calculator, you're going to get about $2,698.80 for your fees. If we were to calculate what would the fees be in 2012, what would our exponent be? If our 2010 is 0, it's 2 years from then, so my exponent would be 2. So we're looking at fees to be about $8,470 in 2012. When they looked at it, it was actually 2,244. What is the difference? So if I find the difference of 8,470, 8,244, I get, okay, I didn't do that subtraction. So that equals 6 and that is 2, 6. Okay, just having a little bit of a pause here. I'm going to just go old school and just type it in so I don't have to think quite so hard. 8470 minus 8244. Oh, look, I should have just done it. 226. So if I'm within 226, does that seem reasonable? I had a prediction. A prediction is an estimate. It seems reasonable. Why is the difference? It's we made a prediction. So that's, or an estimate. Because our prediction was pretty close, I would say we have a pretty good, you should have pretty good confidence in our equation. All right. Now we get to look at the equations and we get to graph the situation. So once again, if we know A is 5, then we've got a start value of 5. So there we go. I have a B of 3, so that means I'm increasing. If I plug in 1 for x, I would get 15, right? 3 to the first power times 5 is 15. 3 to the second power times 5 is 45. And 3 to the third power times 5 is 135. This looks pretty good because I've got a nice growth and I'm increasing by a factor of 3, right? 15 times 3 is 45, times 3 is 135. Nicely done. I'm going to just estimate this. So I might go here, and then 2 is 45, so that's 25, so maybe about here. And then 125, it's going to go right up. So here we go. I can do better than that. I'm going to make it a little steeper. There we go. That's pretty good. All right. Now, next one. It's got to be a decay because my multiplier is 1/2. I have a start value of 10. So 0, 10. If that's 50, 40, 30, 20, 0, 10. Okay. So I'm going to do to -2, -1 because I know I've got to come down here and then these are going to get really small because it is a decay model. So if I do -2, 1/2 to the -2 is 2 to the second, so 4 times 10, and I get 40. If I put it to the -1, I get 2 times 10 for 20, right? I've already got my 0. And +1, 1/2 of 10 is 5. So that should give me enough. If I go -2, I've got 40. -1 is 20. And then 5, right? And then I'm just getting 1/2. So here's my curve, right? Got a little more lead there. How you doing? This one is a long one. I know. Yesterday was short, and this one is a bit longer. And you can see I'm going to, if I keep going 1/2, this is going to be my asymptote at y equals 0. All right. Now, I'm starting with just a teeny tiny bit of 1/10, but I get to grow by a factor of 5. So I've got 0, 1/10. If I plug in 1, it's still not going to be very high. 5 divided by 10 is 1/2. If I plug in 2, 25 divided by 10, right, is 2.5. And so I'm going to just estimate this. This is going to be 1/2. This is going to be about 2.5. So here we go. Right? And there's my other arrowhead. Pretty good. All right. So now we've got the situations. So